This will be a review of the test 4 material. We may not go over all of the questions from the review, but I'm going to go over some of them. So for number 1, let f of x equal 10x plus 10. We want to find the inverse of that. So the first step is to interchange x and y. So remember that f of x is the same as y. So we would start by writing x equals 10y plus 10. And now our goal is to solve for the new y. So we would subtract 10 from both sides. So we get x minus 10 is equal to 10y. To get the y by itself, we would divide by 10. So y equals x minus 10 over 10. And that's it. So that would be what we put here, x minus 10 over 10. Number 2, use algebra to find the inverse of the function. So this is really the same. Number 3 is also the same. Let's go ahead and do number 2 together and we can skip number 3. So we would start by recognizing that this is y. So we would invert those. So x equals y cubed minus 7. We would add 7 to both sides. So we would get x plus 7 equals y cubed. We would take the cube root of both sides to get the y by itself. So the answer to this one would be the cube root of x plus 7. All right, we're going to skip number 3. Number 4, which of the following are one-to-one functions? So we're looking to make sure no x's repeat and no y's repeat. So both have to be neither x nor y can have a repetition. So C, no x's repeat, no y's repeat. So this one is H. We've got, looks like nothing, no x's repeat and no y's repeat. So that's good. G, immediately I can see that the y's repeat here. So G is not one-to-one. M, I can see that the x's repeat here. So M is not one-to-one. It's not a one-to-one function. And then Y, I don't see that any x's or y's repeat. So Y is a function as well. So the one-to-one functions are C, H, and Y. All right, for the following table of values, write its inverse. So we have the x's and the y's. Remember that the inverse just flips the relationship. So now the x's are going to become the y's. So 1, 4, 6, 9, and 12 would go over here. And the old y's are going to become the new x's. So -5, -2, 3, 6, 9. So all you're doing there is flipping the x's and y's. For number 6, plot the inverse of the function shown on the grid below. So it gives me a blank grid, but I'm going to go ahead and graph it on the same grid. So remember that it should be a reflection over this xy, x equals y line. And I'm just going to look at the points in blue and then invert those. So in blue, I have the farthest point to the left is -8, 2. The inverse of that would now be 2, -8. So I'm just changing the order. The second point I see marked in blue is -2, -1. So the inverse would be -1, -2, switching the x and y. The next point for blue I see is -1, -5. So the point in red would be -5, -1. And then finally, I see this open circle down here at 2, -8. So the open circle for the inverse will be -8, 2. So I've got 2, -8. So in red, it's going to be colored in here. -1, -2 would be here. Negative 5, negative 1 would be here. And then negative 8, 2 would be here. So this one would be open on the red. Okay. So remember that whichever one's open here is going to be open here. It doesn't mean that it's going to be the one farthest to the right. So keep that in mind. All right, so number 7. This is the same thing, so I'm going to skip this one, same as number 6. Number 8, find the vertex. Okay, so this one is in vertex form, which is nice. You just have to remember that it's always the opposite of the sign in parentheses. So that means that your vertex, the x value would be a negative 6. And then it's exactly what it looks like on the outside. So the y value would be a negative 7. So the vertex is negative 6, negative 7. So opposite sign of what's in parentheses, same sign as what's on the outside. Find the find the vertex of the quadratic equation when it's in standard form. So here, remember you find the x value by using the formula negative b over 2a. A is in front of x squared, b is in front of x, and c is by itself. So this will be a negative 6 over 2 times 1. So this will be 6 over 2, which is 3. So 3 is the x value of the vertex. To find the y value, you plug 3 in. So 3 squared minus 6 times 3 plus 6. So it'll be 9 minus 18 plus 6. So it'll be negative 9 plus 6 is negative 3. So 3, negative 3 is your vertex for number 9. Number 10, graph the parabola. Do not place any dots, then fill in the blanks about the vertex. Any intercepts, the domain and range, intercepts as ordered pairs. Okay, so let's see. I don't think it's going to all fit on the screen. So we have to find the vertex, the intercepts, the domain, the range, and the equation of the axis of symmetry. Okay, so let's start by finding the vertex. So the x value is negative b over 2a. That will be a negative 6 over 2 times a, which is 6 over 2, which is 3. Is this the same one we just did in number 9? No. Okay. And then we're going to plug that in. So y value, we plug in 3. So 3 squared minus 6 times 3 plus 5. That'll be 9 minus 18 plus 5. So negative 9 plus 5 would be negative 4. So the vertex, I'm going to scroll down, is 3, negative 4. Don't forget to write it as an ordered pair. So 3, negative 4 is here. Next, we want to find the intercepts. So we can find the x-intercept by letting y be 0. So that's going to be 0 equals x squared minus 6x plus 5. So I'm going to try to factor this. This will be x minus 5, x minus 1. So negative 5 times negative 1 is positive 5, and negative 5 plus negative 1 is negative 6. So that will work. And so then I'll have x minus 5 equals 0, which means x is 5, and x minus 1 equals 0, which means x is 1. So my two x-intercepts are 5, 0, and 1, 0. So 5, 0, 1, 0. All right, next it asks me to find the y-intercept. So we find that by letting x equal 0. So 0 squared minus 6 times 0 plus 5 So that's going to be 0, 5 for the y-intercept. So that'll be up here. And then let's go ahead and find the axis. Well, I'll go ahead and connect these. So what I was going to suggest is the axis of symmetry. Remember, the axis of symmetry is always a vertical line that goes through the vertex. So your axis of symmetry is x equals 3. Okay. And then I can connect these dots to make my graph. Remember, it's a U shape. All right. So there's a good sketch. To find the domain and range, I can just look at the graph. So it goes to the left forever and to the right forever. So the domain is negative infinity to infinity. That's always the case for our parabolas. And our range, it goes up forever, but its bottom is here at -4. So the range is -4 with a bracket to parentheses. All right, the next one, solve the inequality. Give your answer in interval notation. Okay, so this is a quadratic inequality. So we want to move everything to the same side as the r squared. So I'm going to subtract 10r and add 21 to both sides. So that's going to give me r squared minus 10r plus 21 is less than or equal to 0. And now what I want to do is factor this. So this is going to be r minus 7, r minus 3, less than or equal to 0. And now I can do two things. I can either do the lazy graph or I can do the test point method. So I'm going to go ahead and do the lazy graph. So here is my number line. I have 3 and 7 on my number line because that's going to be my intercepts. And then it's a positive, so it's going to be going up. And then I'm looking for, since this is less than or equal to, I'm looking for everything that's below the line. So that would be everything down here. Since it's less than or equal to, it's going to be solid dots. So the interval that works is the numbers between 3 and 7. If you need more explanation, remember that you can go find the videos in my Open Math for this section. All right, number 12. Find the quotient and the remainder using synthetic division. So remember that when you divide, you're using the opposite sign. So since the factor is x plus 2, I'm going to be dividing by -2. Also remember that you're not missing any terms in your numerator. So we have x cubed, x squared, x to the first, and no x. So we're not missing any terms. So then we write the coefficients, 1, 7, 11, and 8. We start synthetic division by bringing the first number down, and then we multiply. So we get -2, we add, we get 5. We multiply and get -10, we add and get 1. We multiply and get -2, we add and get 6. The last number is always the remainder, so the remainder is 6. And the quotient, remember that it's one exponent is one lower than we started. So since we started with an x cubed, this is going to be an x squared. 5 is going to be the x, and the 1 is going to be a constant. So it will be x squared plus 5x plus 1. All right, number 13, same thing. Remember to divide by a -3. Oh, and the other thing is you're missing the x. So make sure you put in a 0 placeholder. So you'll have -3, 1, 2, 0, 4, and then go through with your synthetic division. So don't forget the placeholder of a 0. Number 14, Given the function f of x, calculate the following values using synthetic division and the remainder theorem. So on this one, what they're wanting you to do is use synthetic division to do this. So you would use the number that's in here, this -2, and you would do synthetic division. So you would say -2, 6, -6, 4. We're trying to divide into this. So we bring the 6 down, we'd get -12. Add, we'd get -18. Multiply, 36. Add, get 40. So here the answer would be 40. You're just looking for the remainder. And you would do this for all of these, and whatever you get for the remainder, you'd fill in the blank. Number 15, use the remainder theorem and synthetic division to evaluate the function at the given value. This is the same as number 14. 16, factor the following expression completely given that one of the roots is 1. Okay, so if a root is 1, there is a factor associated with that. The factor is going to have the opposite sign. So if the root is a +1, the factor will be w minus 1. I always like to go ahead and write that in the blank so that I don't forget that that's one of the factors that I have. Now I'm going to use synthetic division with the 1 and my coefficients of my function or my polynomial 1, 1, -26, 24. Bring down the 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. -26 plus 2 is -24. Multiply, get -24. Add, and get 0. So I have a 0 remainder, and my quotient is x squared plus 2x minus 24. And now I need to factor that. So once you use synthetic division, you factor what's left to give you your other two factors. So this will be +6, and -4. That multiplies to get -24 and adds to get 2. So we'll add that up here, and I used x's, it should have been w's. So w plus 6, w minus 4 are the other two factors. Okay, let's see. 18. Oh wait, I skipped one. 17, find all possible rational zeros. So for this one, all you're doing is looking for your p's over q's. Remember that p is your constant. So here's p. And then q is your leading coefficient. So then you just make a list of all your p's over all your q's. So factors of p, plus or minus, factors of p over factors of q. So plus or minus 1, 2, 4. That's the only way you can multiply to get 4 is 1 times 4 and 2 times 2. And that's the same on the bottom. And so then you have to make every combination that you can. So you'd have 1 over 1, 1 over 2, 1 over 4. So you'd have plus or minus 1, 1 over 2, 1 over 4. Then you would find all the combinations with the 2. So 2 over 1, 2 over 2, which is 1, we already have that. And 2 over 4, which is 1/2, we already have that. Now you find all the combinations with the 4. 4 over 1, 4 over 2 is 2, we already have that. 4 over 4 is 1, we already have that. So that is our full list. 18, find all zeros of the function. Use integers and fractions for answers, not decimals. Okay, so this one, it doesn't tell you where to start. So what you would have to do is you'd have to find all the p's and q's, and then from that list, you would need to do synthetic division. So we would find all the p's over q's. So here's p, here's q. So our possibilities are, let's see, 1 times 32, 2 times 16, not 3, 4 and 8, not 5, not 6, not 7. I think that's it. And then the bottom is all the factors of 3. So that would just be 1 and 3. So all the combinations here, you'd have to try them until you figure them out. Figure out which one works. So in order to save time, I'm going to use 4 because I believe that one works. Otherwise, it's just kind of a guess and check method until you find one that works. So 4 over 1 will work. Let's see if that's true. So 4, I'm going to use the coefficients 3, negative 22, 32, 32. Bring down the 3, multiply, get 12, add and get negative 10. Multiply, get negative 40, add, get negative 8. Multiply, get negative 32, add and get 0. So there's one that works. Remember, you may not know which one works, so you'd have to guess and check until you find one that works. So now this is going to give us 3x squared minus 10x minus 8. The remainder is 0. So if 4 works, that means 4 is one of the zeros. That means one of the factors is x minus 4. So now I'm going to use the quotient and factor that again. So let's see, I've got to find something that multiplies to get negative 24 and adds to get negative 10. So that's 1 times 24, 2 and 12, 3 and 8, 4 and 6. The signs have to be different. The bigger one needs to be negative. So knowing that, I will see that 2 and negative 12 will work. So let's see, this is going to be 3x squared plus 2x minus 12x minus 8. So I brought the 3x squared and the minus 8 down from here, and the middle, negative 10, was split apart into the numbers found in the chart. Then I'm going to do the factor by grouping. So when x is all that's in common for the first pair, that would leave 3x plus 2. Bring down a negative. I could factor out a negative 4. When I divide by a negative 4, I get 3x plus 2 there. So 3x plus 2 is another factor, and x minus 4 is another factor. So notice I have 2x minus 4s. So that means I'm going to have x minus 4 squared times 3x plus 2. If you put x minus 4 twice, I think that will be fine. You don't have to write the 0, 4 again. So you would just have to write the 0 for 3x plus 2, which is negative 2 over 3. So remember that each factor is associated with a 0. All right, 19, find all zeros of the function. So this is the same thing as number 18. Number 20 is also the same. So you would start by finding all your P over Qs. You would check them until you find one that gives you a remainder of 0, and then you factor your quotient. 21, use the given polynomial function to identify the zeros of the function and the multiplicity of each 0. Leave any remaining answer boxes empty. Okay, so the zeros, not negative 9, because it does not have a variable, so that one's not included. Another 0 would, a 0 would come from this factor. So the 0 would be the opposite of the factor, so the 0 would be 4. And the multiplicity is the exponent, so multiplicity 3. Another 0 would be from here, so the 0 would be the opposite, negative 3. There is no exponent, so that's understood to be a 1. And then the final 0 would come from this factor. It would be a 0 of 8, and the multiplicity would be 2. All right, this is the same, except there is one difference. This number in front this time will give you a 0, and that's because you have an x here. And the one above this, it was just -9. There was no x attached. So that's the difference. So here we'll have a 0 of 0, multiplicity 1 because the exponent was 1. A 0, 2, multiplicity 2. A 0 of -5/4, multiplicity 2. All right, 23. It is possible that that's for that one. If f of x is 9x minus 8 and g of x is x plus 8 over 9, find the composition of these functions. And then we're going to say, thus g and f are inverses or not inverses. Okay, so this one, we're going to plug in g into x for f. So that's going to be 9 times x plus 8 over 9 minus 8. So in the first step, we will be able to cancel out the 9s. That would leave us x plus 8 minus 8. We would be able to cancel those out, and we would see that we would get x. So that's part A. We plugged g into f. Okay, so this is this. All right, now we're going to plug f into g. Remember that this is just another way to write this, right? So now we're going to go the other way. We're going to plug f into the x of g. So this will be 9x minus 8 plus 8 all over 9. So now we can cross out the 8's, and that would leave us 9x over 9. We could then cross out the 9's, so we would just get x. And since we got only x by itself in both cases, we can say that f and g are inverse functions. 24, verify if two functions are inverses. Same thing we just did in 23. 25, we are standing on the top of a 304 feet tall building and launch a small object upward. The object's vertical position measured in feet after t seconds is given by this function. What's the highest point the object reaches? Okay, so the highest point is the same as asking for the maximum. So if we're looking for a max or a min, we're looking for the vertex. So remember, we can find the vertex by using the formula -b over 2a. So that's going to be -288 over 2 times -16. So that's -288 over -32. And let's see what that is. So 288 divided by 32 is 9. So t is 9. Remember, this is the x value. And in this case, it's the t value. So this is the time. We're not looking for the time, we're looking for the feet. So to find that, we need to plug that in, and that will give us the h, which is the feet. So we're going to plug it in. So the maximum happens after 9 seconds. So we're plugging in 9 for t. So let's see, we have 9 times 9 times 16, -16. That'll give us -1296. 288 times 9 is 2592 plus 304. Okay, and when I did that, I got 1600. So that is feet. So 1600 feet is the highest point that the object will reach. 26, sketch a graph. So here, what you're trying to do is you're trying to use the parent function, and then you're trying to use the transformations. So the parent function, our points were 0, 0, 1, 1, and 4, 2. So So here's our parent function. Remember, the parent function is f of x is equal to the square root of x. And now we're going to shift it. So this plus 1 inside or under the radical shifts to the left 1, and the plus 3 on the outside shifts up 3. So each of these points, we're going to move left 1, up 3. And we'll draw our graph, and that will be it. 27, we want to find the operations of the functions. So we're just going to add, subtract, multiply, whatever it tells us to do. So in this case, I'll do the first one, is adding. Remember that this is the same as f of 4 plus g of 4. So I'm going to find those. F of 4 is equal to 4 squared plus 4 times 4 minus 5. That will be 16 plus 16 minus 5. That's 32 minus 5, which is 27. So that is the f of 4. Okay, now we're going to find the g of 4. So g of 4 is 4 plus 5, which is 9. And now it wants us to add these two together. So 27 plus 9 is equal to 36. So that's our answer. So the other two parts are done the same. It's just subtracting. So you would find f of 0 minus g of 0. So you'd find each of those values and subtract them and get your answer. And then for this last one, you would find g of 5, and then you would find f of 5, and you would subtract those and get your answer for that. Okay, the next one. The plot below represents the function f of x. Evaluate f of 4, and then solve f of x equals 4. Okay, so each of these, this is the x value. Remember, normally it looks like f of x. So it's giving you the x, and it wants you to find the y. So if x is 4, here's x is 4, I'm going to go up and see what y value is associated with that. And the answer is 3. For the second part, it's telling you the y value is 4, and it wants you to find x. So if the y is 4, that's here, I'm going to go over and see what I have to get x. The x associated with that is negative 4. All right, the last one, number 29, is use the quadratic formula to solve this problem. All right, so we use all this blank space up here. So the quadratic formula, we have a is 1, b is negative 2, c is negative 5. So we have x equals the opposite of b, so negative negative 2, plus or minus the square root of b squared minus 4 times a times c all over 2a. So we'll get 2 plus or minus the square root of 4 plus 20 over 2. So that will be 2 plus or minus the square root of 24 over 2. 24, we can break that down into 6 times 4. And 6 is 2 times 3, and 4 is 2 times 2. Pair of 2's will come out. So this will be 2 plus or minus 2 square root of 6. Those 2 times 3 goes back under. And then we have the heart of reducibility. All of those 2's divide out and leave us 1 plus or minus the square root of 6.